Hello, I welcome you all from my mathematics class. See, this is continuation of the problem that I have taught you in the previous class in Markov chain. I have taken yet another problem to make the students understand better and to think independently to tackle any problem that they may come across in Markov chain. See this problem, it goes like this. Who goes to work, he either takes train or car. These are the two modes of transport he has got. He uses rather. And he never goes by train continuously for 2 days in free. He changes. He never goes 2 days in a row to the office by train. But if he drives car to work on a particular day, then it is equally likely that he will take the train to go to the office the next day. That is the meaning of that. And at the first day, he tosses a coin. If head comes, he takes train to work. Otherwise, he drives to work. That means he will toss a coin. If head comes, he will go by train. Otherwise, he will go by car. Now we have to find the transaction probability matrix and also to find the probability that he will go in his car to work after 2 days. Also find the steady state probability in the long run. So this is the problem. Now you see that there are two states involved. One is the person is going by either car or train. So I will say that, see, he goes by either train or by car. And if let us suppose that this is x minus 1 on any day, this xn, it refers to, n refers to the day on which he travels, and t and c refer to the train or car that he is going to use as mode of transport for going to the office. Now, here you see that xn, here xn, so xn is nothing but a random variable. Xn is nothing but a random variable, and n denotes the day. That is, it refers to the time here, time refers to days. And if he goes by, on a particular day, if he goes by train, then what is the mode of transport he uses the next day? That is the next state. So this is the state. This xn will tell you the next to n minus 1. What is the date? If it is a first 6, let us suppose that this is a second day, means the third day. It is first day means second day, like that. It goes on like that. Now, as per the problem, what happens is that, see, here you put it as t and c. He has got only two modes of transport. It is given that if he uses t, let us suppose that xn, today he goes by train. And you see that if the next day, that means he will not go continuously by train, okay, for 2 days continuously. That means if he goes by train, then the next day he will not go by train. Definitely he will go by car only. That is the meaning of that. He doesn't go continuously. He will go one day, and he will not go the next day. And the next day also it is not necessary as per the statement. So he will go by train today means he will not continuously go the next day also. That means he goes today by train, a particular day by train, and the next day, definite that he will not go by train, he will take car. That is why this is given. So he will not go by car. Whereas if he goes by car, that is the meaning of it. Suppose that he never, it is given that is his mode of travel. I will put it like this. The habit of travel. Habit of travel by the person. This is the habit of the person who goes to office. So this is, if he takes train, he will not go continuously for 2 days. Therefore, the next day he will not go by train. He is definite to go by car only. Whereas, if he goes by car on a particular day, it is equally likely that he may again go by car, or he may also prefer train. So, this is half a chance and half a chance. I hope that this is clear to you. So, here these are the states of the system. T and C are states of the system. And it is given, I will explain once here what happens here in this problem. There is a person who goes to office. He prefers, the mode of transport he prefers is train or car, and he has got a habit to go to the office by the modes of transport, and he never goes to the office continuously 2 days by train. And if he goes by car, that is, if he takes train, he will not go the next day by train. He will definitely he will go by car. But if he goes by car today, the next day, tomorrow, it's likely that it is equally likely that he will either go by train or car. That is equal chances. 50% chances are there to go to office by car or train if he travels today by car. So that is what I have written here. Xn minus 1 refers to a particular day of travel, and Xn is the next day. Okay. Now you see that here T and C, the states of the system are train or car only. So he goes by, today he goes by, let us suppose that today he goes by train, tomorrow he will not go by train, he is definitely take car. And let us suppose that today he goes by car, the next day, tomorrow, it is equally likely he may either go by train or by car. So this is your transition probability matrix. So this is your transition probability matrix. So let A is equal to this, let A is equal to this, let A, I will put it like this, A is equal to this is the transition probability matrix. Now this is the transition probability matrix. Now, so this first part is over. He is asking you to find what is the transition probability matrix. So this is I hope that you are able to understand the meaning. This Xn minus 1, the state here, today's, if you say that today, tomorrow is Xn, and Xn minus 1, you go by train today, you will not go by train tomorrow, you will prefer only car as per the statement. But if he goes today by car, tomorrow equally likely, that means he may either take train or car. So this is the transition probability matrix. Now, coming to this, he says another thing, that he tosses a coin. That means the person tosses a coin before he travels. He takes up either train or car, and if head comes, he goes by train, and if the otherwise he goes by car. That means the initial probability, that is initial probability, the initial probability of choosing T or C is equal to, so this is equal to, this is half and half. Okay. Now this is the meaning of the initial probability. That is at start, what is that he is going to go. Okay. Now this is what we are having. Now using this, as I have explained in my earlier videos, that you know that the initial probability is known and your transition probability matrix is known. You can go for now, see, this is the transition probability matrix. Now you can go for this P1. P1 is the first day, of his travel, that is equal to your P naught into A, P naught into A. Then you see that your P2 will be equal to P1 is equal to A, and P3 is equal to P2 into A. Like that it goes on. Your Pn will be equal to your P1 is equal to P naught into A. Then here you see that this is equal to P1 into A. So you can write this, also you can write this as P2 is equal to P1 into A, that is P naught A into A, that is equal to P naught of A square. So this will be equal to what? This is P naught of A cubed, and this will be equal to P naught of A to the power of N. So you see that you can find out all the probabilities. What is the probability of his traveling by train or car, first day, second day, third day? For P1 means the probability on the first day, P2 means the probability on the second day, P3 means probability on the third day. Like that it goes on. And you are also asked to find in the long run, what would be the probability of the person to take train or car. In both the ways you can ask. Okay. Now let us start doing this. So I'll write here. So this is my this is A is the probability. A is the transition probability matrix. Now this is an initial probability. Let me start. This problem is done, and let me explain what is the after 2 days. Let us find out after 2 days means what? The third day what is his after 2 days. Then the third day what is his what is the probability of his going by car? That will be it. Okay. Now what is the meaning of that? That means what? Your P3 will be equal to your P naught into A cubed. So this is what we should find. This means P of x3 is equal to C is equal to P naught. You can find this from using this. You find the value of this. From this you can find what is, you can get what is the probability of on the third day he is using the car. So we can find from this. Now let me do that. Okay. Now so for that what we should do here is, see, we have P naught is equal to half. A is equal to 0, 1, half, PC. Now, what is your P1? P1 is equal to P naught into E. That is equal to P naught into E is nothing but what? Your half into 0, 1, half. If you multiply row into column, 1 by 4, 0. This is half plus 1 by 4, 3 by 4. This is half and this is half and this is 1 by 4, that is 3 by 4. Now that means what? P1, that is in the first day. On the first day, what happens is the probability of going by train is 1 by 4 and the probability of going by car is this one. Now, what is your P2? P2 is equal to P1 into A. P1 into A is nothing but what? 1 by 4, 3 by 4 into 0, 1, half. So this is what you will have. So this is equal to cross multiplication row into this. This is 3 by 8. And if you go 1 by 4, this is 1 by 4 plus 3 by 8. This is 2 by 8. This is 5 by 8. On the second day means this is the answer. After 2 days means this is it. On second day, P of x2 is equal to C is 5 by 8. P of x2 is equal to T is equal to 3 by 8. This is what we have. Now if you want P3 is equal to, this is your P2 of A, that is equal to P2 is 3 by 8, 5 by 8 into, it is 0, 1, half, half. So this is equal to 5 by 8, 0, this is 5 by 16. Then this is 3 by 8, 3 by 8 means 6 by 16 plus 5 by 16, it is 11 by 16. So you see that this is what we get. From this what we understand is after 3 days, after 2 days means you can say this, on the second day is this, and this P of x3 is equal to C is equal to 11 by 16, and P of x3 is equal to T is equal to 5 by 16. So these are the answers that we have got. And as I told you, in the long run, if you take this, so this is, so your P of x3 is equal to C means after 3 days, after on the third day, this is on the second day, this is on the third day, P of x3 is equal to C means 11 by 16, this is C and this is C, this is T and this is C, 11 by 16, 11 by 16 chances that he will go by car, and 5 by 16 chances that he will go by train. Okay. Now, if you want to find the steady state probability, the steady state probability is got by taking pi p is equal to pi, where pi is equal to pi c, pi t, pi c, and pi t plus pi c is equal to 1. Sum of the probability is always equal to 1. Now, what is this? Pi p means what? It is pi, yes, it is pi t plus pi t, pi c into the probability you have got. What is the transition probability that you have got here? So this is equal to the transition probability is, here I have taken to be here A, so I will take it like this. Like this. So you have got this 0, 1, half, half is equal to pi t, pi c. This implies row into column, half of pi c is equal to, see, half of pi c is equal to pi t, and pi t plus half of pi c is equal to pi c. Now you see that from this I have got here that pi t plus pi c is equal to 1. So you substitute here in the place of pi t, you write it as pi t, plus in the place of pi t, you write like this. In the place of pi t, you write half of pi c plus pi c is equal to 1. This implies, this is 3 by 2. 3 by 2 of pi c is equal to 1, which implies pi c is equal to 2 by 3, which implies pi t is equal to 1 by 3. So you see that, therefore steady state probability is equal to, it is